So in this video, I'm going to discuss electric shock. What is really fatal to us? What is really dangerous to us? Remember in previous chapter, we saw the Van de Graaff generator that can generate up to 200,000 volts. And you saw the professor touching. Here, I also mentioned that those inflated balloon, when you do this, let's see, remember this video here. I'm using my son. You see that this balloon is now have an electrostatic force, which means it's charged up to 6,000 volts or 5,000 volts. That's quite high. And I use my own son to charge the balloon. Was that wise? Is my son okay? Yes, okay. So electric shock. Yes, the voltage do matter. And we say it is more current that's more fatal to us. But it's typically what it means is that how much work done in your body, how much did it damage you, work did it do to you by the electric force. So I've given an example between the raindrops and then waterfall. Remember, raindrops fall from the sky. That's how much was it? 3,000 feet. The bottom of the rain clouds is about 3,000 feet and it drops to you. So it's a big change in height. So change in height is similar to the electric potential voltage. So it's a big voltage it can be, but the raindrop, we don't need to be worried about getting hit by the raindrop because it's just tiny. So amount of charge that it hits is nothing. On the other hand, Niagara Falls, the water vertically drop down of the water compared to the 3,000 feet is actually 167 feet. So it's not too much compared to 3,000 feet, Niagara Falls. The water drop is 167 compared to 3,000. Not too much, but you definitely don't want to be under the Niagara Falls waters because the amount of water hits you and therefore the amount of work it does to you is tremendous. You don't want to be under the waterfall. So it's not just a potential difference, like a height difference, but amount of water, which means the charge, current that passed through you is going to be crucial when we talk about electric shock. So ultimately, what is dangerous to you? Is that a current or voltage? Answer is more like current. So electric shock. It is more current. One thing about it is that a bird that's sitting on a high voltage line. So here's the bird that's sitting on the high voltage line. It has this voltage line is it can be even more, 345,000 volts. But a bird can stand on it, it's fine, because in this case, it's 345,000 volts throughout the wire. So potential drop is 0, no current. Also, the bird's feet has a very highly insulated too, so it's harder even. But you definitely, what this bird that definitely don't want to do is to put another feet on the ground. Then current will flow. It gets grilled. So that's potential drop is 345,000 volts. But again, that it's the current that passed through you that's dangerous. Um, let's see here. I have a 1.5. This battery is yeah 1.5. So here I have a 1.5 battery. I can touch it. I'm not scared of touching plus and minus. But would I want to put this battery in my mouth? No. So human's body, for example, resistance varies from 100 ohms to 500,000 ohms. 500,000 ohms is for the dry skin. And 100 ohms is when you have a saliva, like a little sodium salt water, and it's wet. So that's how much the human's body resistance change. Therefore, if you have it by applying the Ohm's law, right? Ohm's law, current is, so if the even the voltage is 1.5 volts, resistance is 100 ohms, you get a current. But if the voltage is 1.5 volts and the resistance is 500,000 ohms, then the current is so much less. In fact, if the current is 0.001 ampere, you don't really feel anything. But it gets fatal when current is all the way up to 0.07 ampere. For 1 second, it's fatal. So yes, it makes a difference when you have a different resistance. Then amount of current that passing through you was going to be different with the same voltage. All right, I'll see you in the next video.